So on the left-hand side here, we're finding the first 13 terms in the sequence that's below. And this sequence is taken from the same kind of pattern as the Fibonacci sequence. So the pattern there is, in order to get one of the terms of the sequence, you have to add up the two that come before it. So 2 plus 1 gives me that 3. 1 plus 3 gives me the 4. 3 plus 4 gives me the 7. 4 plus 7 gives me 11, and so on. So let's see, there's 1, 2, 3, 4, 5, 6 of these terms. We need 7 more of them to make the 13. So 7 and 11 gives me 18. 11 and 18 gives me 29. 29 and 18 give me 47. 29 and 47 gives me 76. 76 and 47, 123. And 123 and 76, 199. Let's see, how many are we up to? 1, 2, 3, 4, 5, 6. I need one more. So 123 and 199 is 322. So there are the first 13 terms of that sequence. And this is, according to the question over here on the right-hand side, it is one of the sequences in the Fibonacci series. These series can begin with any two numbers, so in this one it was 2 and 1. But each successive term comes from adding those two up to get the next one, right? The traditional Fibonacci sequence is, it starts with a 1 and a 1, and then you build all the numbers from that. 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, and so on, right? So this question over here is asking us to pick any two starting values that we want and then make the first 13 terms of that sequence in the Fibonacci series. So how about I start with 5 and 10? I like this one just because 5 and 10s, these are going to be pretty easy to add. So 5 and 10 gives me 15. 10 and 15, 25. 15 and 25, that's 30, 40. Then 65, 25 and 40. 40 and 65 gives me 105. 65 and 105, 170. And let's see, 170 and 105 is 275. 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got 9 of them. I need 3 more. So 170 plus 275, we got 445. Plus 275, 720. Plus 445, 1165. Excellent. Okay. So now the question that a lot of people struggled on, and that was taking ratios of these things. Okay, so it says, let f sub n be the nth term of the sequence from question number 2, where the first f sub 1 is 2, and f sub 2 is 1, and f sub 3 is 3. This means the first term, the second term, and the third term. Okay, so if f sub n is the nth term, then f sub n plus 1 is the next consecutive term. So here we're talking about f sub 1 being the number 2 from the original sequence there. And then f sub 1 plus 1, f sub 1 plus 1 would be f sub 2. And f sub 2 is 1 from the original sequence. F sub 2 plus 1 is f sub 3, and that is the number 3 from the original sequence. Okay, so now that we understand what f sub n means and f sub n plus 1, what we're doing is we're taking ratios of those things. Notice that the f sub 1 is the number that's on the top, and the f sub n is the number that's on the bottom. Okay, and we're trying to see what these numbers approach. So This was a question that was on the review, and on the review we were using the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, and so on, and we're taking ratios of those. So we would want the second term on top of the first term, so that's 1 over 1, and that's just equal to 1. We would want the third term on top of the second term, and that would be 2 over 1, which is just 2. Then I would want the next term, this is the fourth over the third, and that's a 3 over a 2, which is 1.5. Then the fifth over the fourth, and that is 3/5, or no, 5/3, which is 1.6 repeating. And the sixth over the fifth, 8 over 5, which is 1.6, and you can see that we're starting to get close to something. So using that same kind of strategy, we're doing it now with the sequence that we had on question 2. So let me clear all this stuff off of here, and let's look at it with that sequence. Alright, so this sequence on number 2 is, and I'm going to have to come back here because I don't know what it is, I don't remember, 2, 1, 3, 4. 7, 11, 18, 29, let's see what else, 47, 76, 123, 199, and 322, I think. Okay, so what I'm doing is I'm dividing in my calculator like this. I want the second term over the first term, so that's 1 over 2, it's 0.5. Then I want the third term over the second term, 3 over 1, it's just 3. Then I want 4 over 3, which is 1.3 repeating, 7 over 4, which is 1.75, and, oh no, this is 1.6, isn't it? It goes in there, no, that's right. And, let's see, what do we got? We got 11 over 7, 1.57, and 18 over 11, 1.63 repeating, and keep on going because this is fun. Alright, we got 29 over 18, 1.61 repeating, it's just the one that's repeating, 47 over 29, 1.62. Let's see if I can get a couple more fit into this slide and make this video just a little bit longer. Let's see, we got 76 over 47, 76, 1 point, if I round it, 1.62. Let's get one more in here, 123 over 76. And also 1.62. So if I keep going, I'm just going to always round to 1.62. If I go out another decimal place, this would actually get closer to 1.618, and so on. And that's the number called the golden ratio. So my conjecture here, now use your inductive reasoning skills to make a conjecture. The conjecture should be something along the lines of, if I take ratios of Fibonacci numbers in this pattern, f sub n plus 1 over f sub n, then that sequence will always get closer to 1.618, the golden ratio.